Great, thanks Rita. Jeff?
Thanks. So I wanted to start with just a brief introduction about who I am, because building science means a lot of different things to different people. And so I study buildings, and the reason I like to study buildings is I'm going to steal a quote and adapt it from Jonathan that you heard yesterday from Ed Young about, I'll do it without the swearing, about there's this amazing amount of diversity and complexity and complication all around us in buildings, and most of it's unexplored. We don't know the impact of different surfaces. We don't know how parts of the building connect to each other. There's all these interesting physical, chemical, and biological phenomena that happen in buildings, and that's why I choose to study them. And so in what I've done in MoBE-related research is I've tried to characterize buildings, but do it in a microbially relevant manner. So, for instance, we could measure temperature and relative humidity in the center of this room, and it would have roughly no association with any microbiological process going on in this room, because what matters is the local environmental conditions and the water available to the microorganism where the microorganism is, which and that varies greatly in most indoor spaces. So this concept of microbial relevance is really important. And one particular area where I've been doing most of the research more recently is in the role of water and liquid water and absorbed water and available water to microorganisms. And I think to a lot of what we see in buildings, that turns out to be a very, very key element. So what I want to do with the last few minutes I have of this brief introduction is kind of seed a little bit of the discussion topics that I think about when I think about intentional manipulation of the indoor microbiome from the building science perspective. So I want to raise two questions, and the first question I want to raise is the question of should we manipulate the indoor microbiome? And some of the challenges I think we want to think about as a community are, from what we've seen this morning from Susan and from Mark, as well as from others, is that to the extent that indoor microbial communities might be associated with protective effects, those protective effects appear to be for relatively narrow periods, really young prenatal and very young infants. And so if that's the case, I think we want to think about what exactly the community is we want to manipulate and what is the appropriate way of administering that managed microbial community. The second challenge I want to highlight is that buildings are really complex, and just from a very practical perspective, it seems like a very inefficient route to manipulate an indoor microbiome to change some exposure to someone in the building. So for example, the space we're in now, we're occupying a tiny volume of this total space, especially if we consider all the unseen spaces that feed into this space. And so do we really want to think about manipulating the whole indoor microbial community, or is there some much more direct route we should consider? But the real thing that I think I'm supposed to address is, can we intentionally manipulate the indoor microbiome? And I want to raise just a few issues, again, with the goal of seeding the discussion. So the first thing is the one image I wanted to show, which is on the screen now. And this is from some sort of fruit drink stand on Salt Spring Island. And I lost my interest in what they were actually selling when I saw it was, $5 for with a $1 deposit for the mason jar. But what caught my eye was the probiotic PB at the top of it, and this was, I think, to encourage people to drink. And why that caught my eye is, of course, PB is the chemical symbol for lead. And this brings up this idea of unintended consequences. And so we have a long history in buildings and in building science of manipulating one aspect, so for example, making a building more energy efficient, and then having other aspects like degraded indoor air quality or degraded thermal comfort in the building. And I would suggest that we should be very careful when we think about manipulating the indoor microbiome of thinking about those unintended consequences. So one more practical example of that from this morning we saw from Karen and others that dogs have a protective effect in some cases. And one of the consequences of having dogs in buildings is that spaces that don't have dogs also accumulate more dog allergen. And this has been shown, for example, for schools and for daycares. And so what happens is that you end up exposing allergic individuals to triggers for their allergy in the name of potentially protecting other parts of the population. So I think we have to think about those unintended consequences. Very briefly, a couple of other things. One is that we all have the experience of being thermally uncomfortable in building environments, in some cases a lot of the time, but certainly some of the time. And so what that gets to is that we've been controlling the thermal environment of indoor spaces for hundreds of years. We have a lot of experience in doing it. And we still get it wrong, at least for some of the population a lot of the time. And so before we start thinking about trying to intentionally manipulate, even if we understood what the community or the microbial population we were trying to encourage in a space, there is this issue of management. And buildings are not heavily engineered, highly engineered spaces. They're kind of spaces that are designed and operated and they work kind of well enough, but precise control is usually not what happens other than in very specialized buildings. So that's another issue we should consider. And so maybe I'll just finish with just making the point that I think that there is a really important discussion that should happen on these questions of should and can we manipulate the indoor microbiome of buildings, and we should approach that from the interdisciplinary perspective that you're seeing here, as well as by thinking very carefully about what we want to achieve and is the indoor microbiome the right way to achieve it. Thanks.
Great, thanks, Jeff. And that's a really good point. We don't want to come up with the equivalent of microbiome asbestos, where from a material science point of view it was the best thing ever, but from a pulmonology perspective maybe not quite so much. So yeah, so that's great, that call for interdisciplinary examination of these concepts right from the beginning.